Welcome to chemistry lesson 703. In this lesson, we're going to handle some of the terms you're going to need for naming ionic compounds. So we have cations and we have anions, and we've already defined those. So we have said that cations are positive. They're positive ions. 1. 2, they come first in the name and in the formula. And 3, they're usually metals. 99% of the time, they're usually metals. We said that anions are negative ions, negatively charged. They come second in the name or formula. And they're usually nonmetals. Actually, they're always nonmetals. But underneath these categories, we have divisions. So we have under cations, we have type 1 and we have type 2. So type 1 cations are usually main group. There are a couple of type 1 cations in the intertransition metals, but not very many. So zinc and I think nickel. The exceptions are like zinc and nickel. And these ions only ever have a single charge. They have one possible positive charge. So for example, sodium is only ever +1, and calcium is only ever +2. And the exception zinc is only ever +2. A type 2 cation is usually transition metal. Transition metal. And it has multiple possible charges. Whoops, yeah, PO. Multiple possible charges. So examples would be, let's see, iron. I'm going to switch colors here. Iron can have a +2 charge, or iron can have a +3 charge. Or another example would be, if we look at vanadium, vanadium can be +2, vanadium can be +3, or we can have vanadium +5. Well, how is this possible? Remember, what do we have in the transition metals that we don't have with the main group? Did you say d orbitals? These d orbitals let it change how many valence it has. With these guys, and usually at the main group, they're always after 8. But down here with the type 2 and most of these transition metals, we have those d orbitals, and so it lets them form multiples. Now, we have to, how do you know? We're going to have to use an ion list. And by the way we write this is the Stokes system. So if I write this iron +2, the name of this is iron, iron, and then I put the charge in Roman numerals in parentheses. If I wanted to write vanadium +3, I would have to write vanadium And then I put Roman numeral 3 in parentheses. So I can't just write vanadium. I have to write vanadium 3. And this indicates the charge. So these Roman numerals are give the charge. All right, with anions, we have monoatomic and we have polyatomic. Monoatomic means it's one type. It's a little bit confusing. Monoatomic, it should actually really, a better term would be monoelemental, because this means I only have one element. So for example, CaO, this is calcium oxide. This is a monoatomic anion. But if I have a calcium chloride, this is also monoatomic. Even though there's two of them, I only have one type of element. And so this is considered to be a monoatomic anion. Polyatomics, we need to give a little bit of time and attention. And I'm gonna, let me just do this, roll down. So I have an example of a polyatomic down here. This is sulfur. This is oxygen. This is oxygen. This is oxygen. This is oxygen, and I have 2 extra electrons. So this is SO4 minus 2. Now, if I didn't have that minus 2 there, I would name that as sulfur. Gosh, all of a sudden I lost my, it's not tetraoxide, sulfur tetraoxide. But I do have a minus 2 there. So that means that this is a polyatomic ion. The definition of a polyatomic ion is a group of atoms covalently bonded that have a charge and thus act like an ion. So I have a covalent bond here. I have a covalent bond here. I've got 4 covalent bonds where you see the red. Those are covalent bonds. But since I have a couple of extra electrons hanging out here, the whole thing has a minus 2 charge. So this now becomes an ion, and we no longer call it sulfur tetroxide. This is now called sulfate. So this is number 1. Number 2, they now have a unique name. And you're going to have to memorize them. You're going to have to memorize them. The other thing is that if you combine this with calcium, so if you take this and you combine that with this calcium, these don't come apart. These always stay together. So they act as a single unit. It acts like a single unit. All right, so let's look at some more examples like we did in our first video. What I want to do is I want to look at my, I want to identify my anions and my cations. So let's say that I have, let's look at calcium oxide. So my cation is here and my anion is here. Calcium is a main group element, and all of the main group elements form type 1. So this is a type 1 cation. In fact, we're going to find out that it always has a +2 charge. And we already said this is monoatomic. So I have a total of 2 atoms. I have 1 cation and 1 anion. All right, let's go with let's do iron. Let's do FeCN2. This is my cation, this is my anion, and this is a polyatomic. So this is a polyatomic. Cyanide is that, and we write it as Cn-1. So this isn't iron carbon nitride. You have to memorize the name and you have to know that this is cyanide. And that's why I have you memorize them so that when you see a polyatomic, you go, oh, I know that, I recognize that. Well, the other thing is we said up top, so let's start off with iron. So this is my cation. Iron has multiple charges it can form. It can be +2 or it can be +3. So this is a type 2 cation. And I have a polyatomic anion. So I have a total of, that's like saying I have Fe with a Cn and a Cn. So I have a total of 1, 2, 3, 4, 5 atoms in this molecule. I have 1 cation molecule, and I have 2 anion molecules. Because each of these Cn act as a group, they always stay together. And that's going to take a little bit of practice to figure that out. All right, let's do one more. Let's do zinc carbonate, ZnCO3. All right, well, we said most of the transition metals are type 2, but this is one of those examples of one of an exclusion. So this is actually a type 1. And I'll give you some hints on how we're going to figure that out when we get there. This is going to be a polyatomic. My anion is going to be polyatomic. So it's going to have a specific name, and we're going to find out the name for that is carbonate. Carbonate. So I have a total of 3, 4, 5 atoms. I have 1 cation, and I have 1 anion. Why? Because this always stays together as a unit. All right, in the next video, we're going to be ready to start naming, and we're going to then do this by categories. So thanks for watching, and see you in the next video.